I will now go through the light worksheet and try to understand and do your correction. Let's start with question 1 here. Okay, this is a mirror reflection, and the first thing you need to do is always draw the normal that is perpendicular to the mirror boundary here. And this 30, take note of that, it is not the angle of incident. This is the incident ray, and the angle of incident I is always between the incident ray and the normal. So this is something very important. Make sure you must know. This is 60 degree, and obviously because the law of reflection, the R will be 60 also. Alright, so what's the angle of reflection? The answer will be B. Question number 2, which statement about the image formed by a plane mirror is incorrect? Okay, by now you should know the 5 characteristic of the mirror image. So the image is real, that's wrong. It should be virtual. Okay, that should be the answer. Let's look at this. It's upright. Okay, your head is still on top. Same size as the object because we are talking about plane mirror. Alright, and the image distance and the object distance, they are the same. So A will be the answer, which is incorrect. Alright, next one. Now this is I have this example in my summary, and I told you many students got it wrong that year when it first came out. So now take a look at all this diagram, and I would want you to recall we practice drawing the ray diagram for mirror image. If this is the object, this is the eye, then we always say that the first step is to locate the image equal distance. So you literally have to measure the length, the distance, make sure are the same. Then if the question asks for two ray, you always start from the image, a point on the image, and then all the way to the edge of the eye. Now okay, and then this two ray does not come from the mirror itself, it's actually being reflected. Okay, so the light shines on the object, it reflects light in all different directions. Then we just choose to draw these two ray. Now maybe because the fact that I always say that we draw the two rays to the edge of the eye is because you are given the eye. Then so we just take the edge of the eye to actually draw the two rays, all right, to reach here, just as a reference. But it does not mean that it has to go to the edge of the eye. That's why many of you will rule out option C, because you see that the eye is actually smaller than the two rays. Okay, but that's wrong. It doesn't matter whether your eyes is big or your eye is small. This is the diagram. Can you see this is the object, equal distance, that's your image. You extend the virtual ray, that will be your image. Only C is correct. The rest will be wrong because this will never be the case. Okay, and this case the I and R are not the same also, and none of all these rays actually follow this ray diagram that you have drawn for reflection. So the answer is C. Alright, next one, question number 4. Now it's a very simple question, but yet some of you got it wrong, mainly because the mirror is tilted. Then maybe some of you are a bit confused. So if you don't let anything distract you, just like we have said here, if this is the object, the image must be equal distance. Okay, the object distance and the image distance, they must be the same, and they are perpendicular to the, this is perpendicular to the mirror surface. All right, so it's the same here. If you look at this, this is the object, this is the object distance, the image distance is equal, and that will just be your image. That's it. But some of you, maybe you are confused with this ray, but it's true, like I said, light can travel. There are many lights coming out from the object. They just choose to draw these two, and these two, they are correct. If the ray hits the mirror at 90 degrees, it will be reflected back as such. And do you remember this ray here? You continue, that will be the image. That's how you draw your typical light ray reflection. Alright, so the answer is B. So just very straightforward. For question number 5, I've gone through in my summary before when we go through the theory. For such question, you are supposed to draw out the ray diagram as accurately as possible. It's not by judgment. So the first thing you need to do is extend the mirror. I'm not using ruler, so please do that, and make sure now the next step is, this is the object X. You're supposed to draw and measure equal distance, and that will be your image of x. Let it be x prime, and you do the same for your y, image of y and image of z. Okay, try to be accurate, really measure the object distance and the image distance, make sure they are the same. Now y is standing opposite the midpoint. This is your y. How many students can see the image of the other two? All right, now first of all, it does not mean that x and z in front of them there's no mirror. It does not mean that you will not be able to see any of your friends, because if you understand reflection doesn't mean you can actually see them. Just depends on the ray diagram which we are supposed to draw in order to know. So to draw it accurately, let's start with y. Assume you are standing here. Are you able to see your friend x and y? So what do you do to see? That means I will draw the image of your z, all right, all the way to here. Of course, this portion by right is supposed to be dotted, but since it's an MCQ question and to be fast, I'll just draw solid line. Then can you see? The light ray can actually from here touches hit the mirror here. This is the point of incident and it falls on the mirror. That's the most important thing. That's why it can be reflected and goes into the eye of the y. So definitely if you're standing here, you can see z, and it's the same for your x, because happens that this question in a way easy because it's symmetrical. So y will be able to see z and x. So there's one student that can do that already. Then to prove to you, what if you are standing at x here? It's the same as standing at z here because they are the same. I will just do one to show you. Let's say you are standing at your x here. Will I be able to see y? Just draw the ray diagram. So once again, this point, it falls, the point of incident falls on the mirror. Then you can see the friend. Likewise for z over here. All right, so same thing, it falls here. So it's the same for this side because they are symmetrical. So that means to say all three, they will be able to see each other. Okay, or the other two friends. But don't treat it as and memorize the answer, because I can also give you a question where let's say, okay, maybe I just, what if the mirror is really lopsided to one side, and then this is your y and this is your x and this is your z, and the mirror is just a small section. So like I said, the only way to know is to actually draw out the ray diagram to be sure. All right, next question here. Okay, the incident ray hits the glass block as shown here. Which of the following ray ABCD is not correct? All right, now this is the incident ray that comes here, and this is the normal. And as you know, because this air glass boundary, is smooth, therefore there'll be some of the light that's being reflected. So this R equals to R, there will be a weak reflection taking place, which is correct. Okay, so A is possible. Then you have learned when light is traveling from the air less than to a denser medium glass, it will bend, the speed slows down and you'll bend towards the normal. So C is correct. Then you draw your normal here. Glass to air, denser to less than, the speed increases and it bends away, and this is supposed to be parallel to this incident ray, reflected ray and emergent ray. Okay, so because these two boundaries are parallel, the incident ray and the emergent ray will be parallel also. So the only answer that's wrong is B, because light, unless there's no change in medium, light is will travel in a straight line. If this air and it continues to be air, you'll just go straight. So because the two mediums are different, they are of different refractive index or optical density, the light will change its speed, and since there's an angle of incident, it will bend towards the normal. So B is wrong. All right, next one, and we went through this many times already. For a semicircle, you have to be careful, because do you remember the concept? The radius is actually the location of your normal. All right, so let's start with the incident ray coming here is air. less than, okay, and this will never be the case, you should know that. So A is wrong, and because it's, and likewise this is the normal, and light, when the reflected ray will never be along the normal, so D is wrong. So the only option, yes, is this one, bends towards the normal, because the speed decreases in the glass. When it reaches here, that's where I told you, when the point of incident falls on the circumference of a semicircle or circle, you should know that this radius is actually the position of your normal. Alright, it's 90 degree over here, and the normal is here. Since the angle between the incident ray and the normal is 0, I equals to 0 degree, and that's the concept that you must know. The light will just pass through and go into the air without bending. Alright, so C will be the answer, not B. Okay, all because of the angle of incident is 0. Next question, question number 8 here. So you can treat it as the air here, and since it bends towards the normal, the speed decreases. That means medium Y is denser than medium X. So let's X here. The Y is denser, so the refractive index is higher than the X. And then from this point and into the Z here, it bends away from the normal. That means to say the refractive index of Z of Y is actually greater than Z. Okay, these are things that you know. And next, as from Z here, it goes out into the like the air, the medium X, it bends away from the normal. That means to say the X here has lower refractive index compared to Z. So Z is greater than X. So you can say that the least refractive, since the question asks for ascending order of optical density, is similar to asking you in order of the refractive index. Let's start with the smallest one. It's like here is like the air that you are familiar with. So start with X here, and then since Y is greater than the Z, so it will be followed by your Z here, then followed by the Y. Alright, so the answer will be B. Next, this is on lenses. Alright, now one look at it, you know that this is the fourth scenario that we have gone through, the four scenarios that are very important. And you know that the object, which is over here, is placed at a distance less than 1 focal length. That means your F must be somewhere around here. These are things that you know. But nonetheless, where they ask you where's the focal point, do you remember the 2 or rather 3 rays that you need to know how to draw, because there are rules to follow. One of them is this: if the ray passes through the optical center, it will go straight. The other ray is if it is parallel to the principal axis, after passing through the lens, it must pass through F. That's the reason why the answer is D. D is the focal point. Next, let's go to question number 10. If the object is placed at 20 cm from the lens, the image form is inverted. That means if this alone you know is scenario 1, 2, or 3. Okay, you can refer to your summary. And it's the same size as the object. Now, that's the key information here. If it's same size, that's scenario 2. That means to say the object is placed at 2F, exactly at 2F, and your image will be exactly at 2F on the other side of the lens. Alright, so maybe I quickly draw it for you, and I hope you can still remember. If it's same size, that means to say the object is here and this is 20 cm. You will get the image will be exactly at 2F, and they must be the same height, same size. So I hope you still remember this. So, but don't be tricked, 20 is not the focal length, it's 2 times the focal length. This is F and this is 2F, so it's 2 times the focal length. So if they ask you what's the focal length, you take 20 divided by 2, and that will be 10 cm. The answer is A. So let's go to section B, structure question. This is an O-level question also, and the light is traveling from glass denser medium towards a less than medium, therefore it bends away from the normal. All these are what you have learned, and the student do and record the values here, and the value that's missing over here. Now remember, it's the same glass. The refractive index of the glass, you should know, is about around 1.5. That's a rough value, okay? And we are using the same glass, so the refractive index does not depend on the angle of incident or the angle R. If you tilt the ray box and make the angle bigger, like from 19 to 30, the A here, the angle of refraction, of course, will be bigger also. But when you take the ratio, sine R or sine I, the refractive index will be the same. Okay, this is a key concept. It depends, refractive index and depends on the material. It does not depend on how big the angle of incident is. All right. So to solve for your part A, explain why the light ray changes as it passes from glass to air. Now this is a typical kind of question. Now I've written the answer here. Let's go through what are the important keywords and concepts that you must put inside your answer. Since they ask you why the direction of the light changes, if you're able to tell me bends towards a normal or away, you have to tell me that. And in this question is glass to air. So first thing, you have to tell me that the glass in this question is a denser medium compared to air. Okay, do not just say that as light travel from denser to less than, then it will sound that it will appear, seems like you are just recalling a concept. Okay, but in this question, the glass is the denser medium. Tell the marker that, and the speed increases. Now this portion here, about the speed is important. Many students leave out on this. It's precisely the speed changes, that's why cause it to bend. Since the speed increases, the light ray will bend away from the normal. All right. So now, what it means is, by right, if there's no change in the medium, by right, light should travel in the straight line. So now it bends away because the normal is over here. It bends further away from the normal. So that's what it means. Next, you are supposed to, using the data in the table, you're supposed to find the refractive index of the glass. Now, as mentioned here, the formula to be used here, because you're given angle, of course, I'll be using either sine I over sine R or sine R over sine I. And remember I said, if it's traveling from denser to less than, I'll be using this. Another way to remember is, if the numerator must always be bigger, so your A is bigger, your angle of refraction is bigger, that's why I use this formula. All right, and likewise, I mentioned before, you're given two set of data and there's a missing angle A here, which is your angle of refraction. You can use the first data here to find the refractive index, and the refractive index is constant. All right, so I will be using the first set of data here, and I'll use the formula n equals to sine R over sine I. In this case, is your sine A over sine G. All right, that's given in the diagram. So in other words, it will be sine 33 over sine 19, and you will get about 1.7. Okay, you're on the right track. So you know you're on the right track. Refractive index of glass is about 1.5, 1.6, or rather even 1.7. All right, now next, the last part, part C here, you're supposed to find the missing angle A here. I'll be using the same formula, sine R over sine I, and now this is 1.7, or you can use the value before rounded off, 1.673 is equals to your sine R, which is your A that you want, over sine 30, and you can solve for your A to be 56.77, so it's about 57. So, but you must remember how to do your shift sign, and also your calculator has to be in degree mode. All right, so this 57 degree. Now, question 2 is on lenses, and you are given, instead of the usual where you are given the object O, and then you are supposed to draw the two rays to find where's the image, but now they give you the image. So you are supposed to draw two rays from the object to the image. Now, the two rays, you have learned the three rays because they have rules to follow. What are the rules? The first one is I'm not using ruler, so please make sure you use a ruler. So if the ray is parallel to principal axis, and then once it passes through the lens, it will pass through, by right, should pass through the focal point and then go to the tip of the image. Because you do not know where is the focal point F and 2F, not given here, but you know the image. And remember I said any rays, there are many infinite rays coming out from the image. Light shines on it. All the ray that come out from the object will all go to the image, the tip of the image. Okay, so take note of that. So let's draw another one. If it's pass through optical center, it will just go straight and then hit here. And do not forget your arrows. All right, so actually it is not wrong to draw any two rays. If you draw it here, hits here, and then you draw it here, I can accept those blue rays also because they are true. Okay, next you are supposed to find the focal length. Now that's where this ray is very important. Remember in your theory, if this ray is parallel to principal axis, after passing through the lens, it must pass through F, the intersection here. So this point is your F, focal point, and the distance here will be focal length. Now, and you have to pay attention to the scale that's given to you. Every 5 small squares is 1 cm, so there are 10 squares here, so that will be 2 cm. So the answer is 2.0 cm. Next, you are given the speed, so it's like your normal refraction. You are given in terms the speed of light in the air is 3.0 times 10 to the power 8. The refractive index of the lens, the glass, is 1.5. So I will use the refractive index formula involving speed, C over V. Now remember I said if you cannot remember the letter C and V, it doesn't matter. Just know that C represents the speed of light in the air or vacuum to be exact, and the bigger one must be on top. Speed of light in the air or vacuum is the greatest. Alright, which is 3.0 times 10 to the power 8. Then the V will be the speed of light in the glass, in the lens, and the refractive index is 1.5. So you will solve for V. It will be a very big number, but you're on the right track. You change to standard form, is 2.0 still times 10 to the power 8 meter per second. So that's the answer. And let's go to the last section, part C here, where you are given the angle of incidence, and you are supposed to find the angle of refraction in the lens in the same glass, and the refractive index will be the same. So it's like this is the lens here, so the light ray comes in, this is the normal perpendicular to the surface, and that will be your 40, and you will bend towards the normal. You're supposed to find this angle R. So sine I over sine R, alright, 1.5 equals to sine 40 over sine R, and you can solve for your R, do your shift sign, and then make sure your calculator in radian mode 25.37, so it's about 25 degree. Now this is another question on lenses, and it's a past year O-level question, combined science. Now this information is very important. The focal length is 5 cm. In other words, that means to say if this is the lens, the F here will be 5 cm from the lens, and 2F here, that will be your 10 cm, and here is 5 cm. That's what it means. So now the scenario given to you is this object right now is 15 cm. 15 cm, you know, is somewhere around here, more than 2F, or to be exact, is exactly at 3F. Okay, 3 times the focal length. But nonetheless, we actually learned the fourth scenario. You must know that this is the first scenario where the object is more than 2F, is considered a distant object. And the image you will get, you should still remember, is real, inverted, and diminished. Alright, the application is your eye or your camera. So, and they told you that when it's 15 cm, it's adjusted to be a real, inverted, diminished. They gave it to you, but by right, you should know that. Alright, now they give you the second scenario where it's slowly, the object is moved slowly towards the lens until it's 6 cm. Now, that's important. You must know that the second scenario they're talking about is somewhere around here where this is 6. So you should know that it's between F and 2F, and you know straight away this is the third scenario, and the image you get will be real, inverted, and magnified projector in your classroom. You should know that by your fingertips by now. And what's the first question they ask you? What's the direction the screen must be placed in order to have the image in focus? Now what it means is, like now if you're to draw the two, this is your F. Remember how you locate the image. This is your where you locate your image. And what it means is it's only if you put your screen here at the position of the green line here, then you get a sharp image, because whatever ray that comes from the tip of the object all goes to the tip of the image. You will get a sharp image. What if you put your screen here? It's like, can you see, it's like 2 points, 2 images like that, it will be blur. Likewise, if you place it too far behind, it will be blur image. And another very important thing is, how do you know where should you shift the screen? Remember the 4 scenario where in the summary I asked you to take note of the pattern. If as the object move from 2F to F, from more than the first scenario, more than 2F to 2F to between F and 2F, as the object move nearer to the lens, the image will move further away from the lens. It moves to the right as the object moves to the right also. So if you know that, the screen has to be moved to the right. All right, this is something that you must know, okay, and know the pattern, know the 4 scenario very well. And next part, they ask you describe the change in the focus image as it moves closer. That means to say from 15 it moved to 6. What is the change? Now remember the first 3 scenario, all the images are real, so there's no need to talk about that. Both are still real, both are still inverted. All right, if you are not sure, please refer to the summary. And so the only difference is it will move, the image moves to the right. And another important thing is the image will become magnified. All right, because it's actually from the first scenario goes to the third scenario, the image will be much bigger, magnified. Remember, projector. Next, now they give you another scenario, and now the object is placed at 4 cm from the lens. Describe the image. Now, can you see? That's why I said that summary page is very important. If you were to move your object nearer now, which is 4 cm, that is less than a focal length. It's within the focal point to the lens. So you should know straight away. 4th scenario, magnifying glass, and the image you will get is virtual. All right, is upright, and it will be magnified. Okay, you can write any of this. Now the last question here is on refraction. It's an O-level question also, and it actually is quite tricky. Okay, came out in combined science, not pure. All right, so the first thing you need to, they ask you, this is the top view from the room, and you have a fish tank over here. This is the top view, and it's filled with water, and this person is standing at a diagonal at this position here. Okay, and it claims that the boy see 2 images of the fish. There's only one goldfish in the tank, and he looks from the position. So he's standing at this position here. He will see 2 images. The diagram shows a ray. So they provide a ray ready from the fish that is refracted at side B, which is here. All right, of the tank, the ray enters the eyes as shown. So this is a helping ray for you already. Draw a second ray from the fish to the eye that is refracted at the side A. Now, of course, he claims that the boy sees 2 images. One is from side B. You should know that the other one must be from side A. But how do you draw and show the position of the 2 images of the fish? Now, actually, you have learned this before. Let's recap. If do you remember the scenario where this is the eye, the person standing here, and this is the fish, and we went through in class. This is air, this is water, and we have already gone through the image of the fish. This is the real position of the fish, but the image to the eye seems to be slightly nearer to the surface, higher up. So this, you always draw the first step, locate the image first, and then choose a point from an image, and then directly goes to the eye. All right, this is your normal, and the same identical point from the object, the real fish, and then you connect. This is the solid line represent the real ray, and real ray indeed from the water denser goes to the air, it bends away from normal. It's consistent with what you have learned, but this is the last ray that enters into our eye, and our eye always thinks that light travel, we perceive light travel in a straight line, so we think that it's coming from here. That's why we think that the fish is here, but that's actually the apparent image. It's like a virtual image of a fish. All right, this is what we have learned, but this question over here seems a bit complicated. All right, but if you were to actually tilt the paper, okay, let me show you. Can I tilt? Okay, if I tilt it this way and you treat this as the boundary, the water and the air boundary, isn't it the same? So if this is the actual fish, and how do you draw? And just like I mentioned already, our eyes perceive that the light travel in a straight line. This will be the image of the fish and it's nearer to the surface. So that is the first position of the image that you're going to draw. Next, what you can do is same thing. You're going to rotate in such a way where now you treat this as the air water boundary. All right, maybe I use blue to show the other one. So this is the boundary here and your eye is over here. So same thing, this is the actual fish, and where should the image of the fish be? It will be slightly higher, nearer to the surface. And then from the image, I choose a point here. I will draw straight to the eye. Okay, so here all the way to the eye. And where does the ray come from? It comes from the actual object, the fish, then it goes here. So there you have it. You have your two images of the fish and the two rays, and you're going to see them from either side, side A or side B. So I hope you understand how to do this question now. Okay, that's all for the worksheet. Okay, thank you.